This is Mrs. Boots. We're going to review the practice problems for the complex roots and numbers unit. So number 1, we have the square root of 49 and it's negative. Remember, we're going to separate that into the square root of -1 and the square root of 49. The -1 is an I. The 49 is 7. So my answer is 7i. We always write the number first. Let's look at number 2, the square root of 60. Is 60 a perfect square? No. But can I divide it by a perfect square? Yes. 60 is divisible by 4. So I have the square root of 4 and the square root of 15. I can take the square root of 4, that's 2. Square root of 15 can't do it, so we just write it down. So our answer is 2 square root of 15. Number 3. I have a -3 out front. Don't worry about it. Just write it down. That -3 is going to stay there. We're going to break that square root 144 up. Because it's negative, we're going to put the negative by itself. Remember, the negative will give us an I value. So I'm going to have -3i, and the square root of 144 is 12. So this becomes -36i. Number 4, we have a 5 out front. That's okay, just write it down. So I have a 5. Now let's split up the -28. We're going to pull out the -1 by itself. And 28 is 4 times 7. So I have square root of 4, square root of 7. The square root of 4 is 2. So I'm going to write that out front. The I goes in place of the square root -1, and the square root of 7 we can't take. Now let's simplify. 5 times 2 is 10. So I have 10i square root 7. Number 5. 3 out front comes down, and let's split up our square root -12 into -1, and then what multiplies to give us 12? 4 times 3. So I have square root 4, square root 3. The square root of 4 is 2, so it's 3 times 2. The square root -1 is an I, and we have the square root 3 because we can't take it. 3 times 2 is 6. That's 6i square root 3. This is the simplified radical. Let's look at number 6. This one's a little weird, but let's get rid of the negative first. So we have the square root 7. We would have a square root -1. 14 is 7 times 2. Now what I notice, I have that -1 is going to become an I, right? But I have a square root 7 and a square root 7. When those multiply together, it's square root of 49. And then my square root 2 drops down. Well, what's the square root of 49? 7. So I have 7i square root of 2. Number 7, 45. What multiplies to give us 45? 9 times 5. 9's the perfect square. It becomes 3. So I have 3 square roots of 5. No negatives to worry about. Number 8, I have a negative, but that negative's out front. So it's just a negative. It's not an I unless it's inside. 24 is 4 times 6. Square root of 4 is 2, so I have -2 square root of 6. Number 9, square root -48. Again, break out the negative. 48 is 16 times 3. 16 is the perfect square. The square root of 16 is 4. The -1 under the radical becomes an I. And then I put down the square root -3 because we cannot take the square root of it. Number 10. Everything's positive. That's just beautiful. But I have 80. What can I do with 80? Well, we know we can divide it by 4. So square root 4 times square root 20. Well, 20 can be divided by 4. So I have square root 4 times square root 4 times square root 5. Notice from the previous problem, 2 square roots with the same number underneath just equal that number. So this is 4 square roots of 5. We could have 4 times 4 is 16, divided 80 by 16 to simplify. Number 11. We have 2 negatives, one inside the radical and one outside. They do not cancel. The negative outside the radical drops down. The negative inside the radical stays inside the radical. Now what multiplies to give us 128? Well, that's 2 times 64. Remember, you can always, with even numbers, start with dividing it by 2. With odd numbers, start with dividing it by 3. 64 is a perfect square. The square root of 64 is 8. So I have negative 8. The negative 1 under the radical becomes an I, and then I write down my square root of 2. Number 12, I only have one negative. It's outside, so it drops down. 75. I think of 75 cents. That's 3/4. So square root 3, square root 25. Square root of 25 is 5. So negative 5 square root of 3. Number 13. Yes, this is a quadratic formula. All we did was plug in the numbers for you. So now you need to simplify it. I have 2 negatives right out front. They're going to make a positive. Positive 5. The plus minus stays. On the bottom, 2 times 3 is 6. Now we take all the stuff under the radical and we plug it into the calculator. Remember to put the parentheses around the negative 5 squared. Otherwise, you don't get the right answer, because that is a positive 25. Minus 4 times 3 times 6, so that's 12 times 6. It ends up being added because of the sign change. And the answer is 97. 97 is actually a prime number. It doesn't break down. So this is my answer. Number 14. Another quadratic. Let's simplify. We have the negative 8 plus minus. On the bottom, 2 times 2 is 4. Now what's under the radical? That would be 64 minus 40, which is 24. Can we break down 24? Yes, let's do that off to the side. The square root of 24 is the square root of 4 times the square root of 6, which is 2 square roots of 6. So we plug that in. We have negative 8 plus minus 2 square root 6 divided by 4. We need to simplify that. Negative 8 divided by 4 is negative 2. So negative 2 plus or minus, well, 2 divided by 4 is just a half. So I have half square root 6. Number 15. Simplify first. Negative 7 plus minus square root. We'll figure out what goes under the square root in a second. In the denominator, we have 2 times 3. That's a 6. So I have 7 squared minus 4 times 3 times 16. Well, 4 times 3 is 12. 12 times 16 is a really big number. When I plug that in the calculator, I get negative 143. 143 is prime, but it's also negative. So I have, for my answer, negative 7 plus or minus. The negative has to come out. So we put an I, square root 143, all divided by 6. Number 16. Let's start with simplifying. Negative 1 plus or minus 2 times 3 is 6. Now let's figure out what's under the radical. 1 minus 4 times 3 times negative 6 is positive 73. Well, 73 can be broken down. It's the square root of 9 times the square root of 7. So this answer becomes 1, negative 1, plus or minus 3 square root 7 divided by 6. You don't have to simplify that fraction. Number 17. Start with simplifying. Negative and a negative makes a positive, so this is a positive 7. Plus or minus, and in the denominator we have a 2. Now let's find out what's under the radical. Negative 7 squared is 49. Positive 49. Make sure you've got your parentheses. Minus 20. That becomes 29. 29 is prime and cannot be simplified, so this is our answer. Number 18. Negative 4 plus minus. The denominator I have 2 times 0.5. Well, that's 1. That makes it super easy because now I know it's going to simplify. 4 squared is 16. Minus 4 times a half times 15. Well, that's unfortunate because that gives me a negative 14 under the radical. So it's negative 4 plus or minus. That negative sign has to come out as an I. 14 we can't break down, but we don't have to write the denominator of 1. Number 19. Now we get to work with the i's, imaginaries. What are we doing? This is an add-subtract problem, so all I have to do is combine like terms. Remember, you treat the I like a variable. So I have negative 9i and 3i. That gives me negative 6i. I have a positive 7 and a positive 5, which makes 12. So my answer is just 12 minus 6i. Now let's look at number 20. I have a quantity outside parentheses. Always distribute and multiply. 4 times 3 is 12, so I have 12i. 4 times negative 7 is negative 28. I times I is I squared. Remember, I squared is equal to negative 1. So we can substitute that in. So it's negative 28 times negative 1, which becomes positive 28. And then we have to tack on the imaginary part of 12i. Number 21. We have two binomials. This is multiplication. Same thing you do before, treat it like a variable. 4 times 3 is 12. Then I have plus 4i minus 3i minus I squared. We're going to combine like terms and we're going to substitute because I squared equals negative 1. So it's 12 plus I plus 1. That becomes 13 plus I. Same thing on 22. Distribute and multiply. 3 times 2 is 6. 3 times I is 3i. I times 2 plus 2i. I times I is I squared. We're still substituting in negative 1 for I squared. And we need to combine our like terms. So I have 6 plus 5i minus 1. This becomes 5 plus 5i. Now we have division. Remember, for multiplication, addition, subtraction, we treat I like a variable. For division, however, we treat I like a radical. We cannot have I in the denominator. So we want to move it to the numerator. We do that by rationalizing. So we're going to multiply by I over I, if there's a single I in the denominator with no additions or subtractions. Multiplying by I, still same thing with fraction. Top times top, bottom times bottom. So I have 9I over 2I squared. Just like with multiplication, we can substitute in a negative 1. So my answer is 9I divided by negative 2. Number 24, we have to use the conjugate. It's the complex conjugate, right? Remember, the conjugate is the same thing in the denominator with the sign reversed. So instead of a plus 6I, we're going to have a minus 6I. The reason we have to use the conjugate, because of that plus sign, we have two separate terms, a binomial. On the top, you still multiply the 7. So I'd have 7 minus 42I. Easy enough. On the bottom, remember, you can actually take a shortcut. We can multiply the first two and then multiply the last two. So that's what we're going to do. 1 times 1, well, that's easy enough, 1. Positive 6 and negative 6 is negative 36, and we have I squared. I squared, still negative 1, so we're going to substitute in a negative 1. Okay? So this becomes 1 plus 36 in the denominator. So my answer becomes 7 minus 42I divided by 37.